Hello viewers, good day to you all. You're welcome to today's class. I remind you that at Shabande, the video is sponsored by Crush Connect. We have 100 level question to solve in chemistry, which is on the specific heat capacity. But before we begin, I would love to explain what we mean by specific heat capacity and also solve some calculations under the topic. The amount of heat that is being absorbed or released to reach a certain temperature varies from one substance to another. So the capacity of a substance to release or to absorb energy, which is a physical property, is simply what we call the specific heat of the substance. Mathematically, specific heat is the amount of heat that is needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. The mathematical representation or the mathematical formula of specific heat is given us. So we have specific heat as S is equal to heat all divided by mass times the change in the temperature. Okay, so this is the formula for specific heat. So we have that S is equal to heat is given as the letter Q all divided by mass times the change in T. So this is the mathematical formula for specific heat, and this formula is what we'll use or what will guide us in solving some problems. So let's look at the first question, which says that 4.184 joules of heat will raise 1 gram of water by 1 degree Celsius, and the same amount of heat will raise 1 gram of copper by 10 degrees Celsius and 1 gram of aluminium by 5 degrees Celsius. That is what the same heat. So we are asked to explain this. So this is very easy. All we need to do is to bring out the parameters from the question. So it says that 4.184 joules of heat. Okay, so this means that this is the value of our Q. This is the heat, right? Will raise 1 gram of water, okay, by 1 degree Celsius. And this same heat will raise 1 gram of copper by 10 degrees Celsius. And the same heat also raises 1 gram of aluminium by 5 degrees Celsius. So this is what we have from the parameters. So all we need to do is to calculate their specific heat capacities. So let's calculate the specific heat capacity for water. We know that specific heat capacity is given as S is equals to the heat over the mass times the change in the temperature, right? So we have the heat to be 4.184 divided by the mass of water, which is 1, multiplied it by temperature, which is also 1. So this gives us the value of 4.184 joule per gram per degree Celsius. So this is the specific heat capacity for water. So calculating the specific heat capacity for copper, so we have S is equal to the heat, since it's the same heat, that is 4.184 divided by the mass here, which is 1, then multiplied by the temperature here, which is 10. So this gives us a value of 0.4184 joule per gram per degree Celsius. So this is the specific capacity for copper. Calculate that of aluminium. So for aluminium, the specific heat capacity is going to be 4.184 divided by the mass, which is 1, times the temperature, which is 5. So this gives us a value. So we have 1 times 5, right? So this gives us a value of 0.8368 joules per gram per degree Celsius. So making comparison, looking at the three answers we have for each of the specific heat for for both water, copper, and aluminium, we can see that, or we can deduce from this that water has a higher specific heat capacity compared to aluminium and also copper. So this shows that water can absorb or release energy or heat compared to aluminium or copper. therefore, water has the ability to keep the temperature of its body to be constant. So making comparison between the copper and aluminium, which have lower specific heat capacity, shows that they transfer heat more efficiently than water because when the specific heat capacity is lower, it heats up faster with the same energy. That's why copper and aluminium are used for our cooking wares, that is our cooking utensils in the kitchen. The lower specific heat capacity is needed for cooking utensils because they have better heat transfer. So basically, this is all we need to explain on the question for number one. So let's move on to the next question. What is the specific heat? So what we require is to find the value for S, the specific heat of lead is 530 joules. So um, the heat Q is given as 530 joules is added to raise the temperature of 35.6 grams. So the mass is given as 35.6 grams of lead by 12.5 degrees Celsius. So the change in temperature is given as 12.5 degrees Celsius. So we need to know the SI unit of specific heat basically. So the SI unit of specific heat is given in joule per grams per degree Celsius. Okay, so this is the SI unit for specific heat. So we have the specific heat is equal to the heat over the mass multiplied by the change in temperature. So all we need to do is to substitute in the values and get the final answer. So this is equal to the heat, which is given as 530 over. So we have the mass as 35.6 multiplied by the change in temperature, which is 12.5. So simplifying this gives us a value of 1.19 joule per gram per degree Celsius. So this is the final answer. So this is a specific heat capacity for the given question. So let's look at another question. So the question we have says 1.0 gram of iron has a temperature of 21 degrees Celsius. It says what is the final temperature of the iron sample when 4.184 joules is added. So we are given the specific heat of iron to be 0.492 joule per gram per degree Celsius and the specific heat capacity of water to be 4.184 joule per gram per degree Celsius. So first step is for us to bring out the parameters to aid us in solving the question. So 1.0 gram of iron, so we have the mass to be equals to 1.0 gram, has a temperature of 21 degrees Celsius. So what this temperature mean here is initial temperature. So the initial temperature, T initial, is equals to 21 degrees Celsius. So we are asked to find the final temperature. So T final is what we require to find of the iron sample when 4.184 joules. So this is the value for the heat. Okay. So we have the Q is equals to 4.184 joules. So we have the specific heat for iron, which is given as 0.492 joules per gram per degree Celsius. And the specific heat for water has been given as 4.184 joule per gram per degree Celsius. Okay, so first to solve this, remember the formula for specific heat. S is equals to given as the Q over the mass times the change in temperature. Here, let's make the change in temperature the subject of the formula. So here we have Q. Let's cross multiply. So we are going to have Q is equals to S multiplied by M multiplied by the change in temperature. So we divide both sides by SM. So this is from our knowledge in mathematics. So the S cancels the M, the M cancels the M. So we have change in T is equals to Q over S multiplied by M. So here we've made our change in T, the subject of formula. So from here, we can impute our values. Our Q, which is given as 4.184 all the specific heat. Remember, in this case, we are concerned about the specific heat of iron because we are asked to find the final temperature of what? Of iron. So we're going to use the specific heat of iron, which is 0.492 multiplied by the mass, which is given as 1.0. So simplifying this, we have our answer to be 8.5 degrees Celsius. So our change in T is 8.5 degrees Celsius. But remember, the question is not asking us to find the change in temperature, but rather the question is asking us to find the final temperature. So there's a relation we use to get the final temperature. So we're going to use the relation which says that the final temperature is equals to the initial temperature plus the change in temperature. Okay, so this is equal to, so we have our initial temperature, which is 21 plus our change in T, which is 8.5. So when we add this together, we're going to have a value of 29.5 degrees Celsius as the final temperature. Okay, so this is our final answer. So this is just as simple as that. I have an activity today for my student. So the activity for today says, how can you determine the specific heat capacity of 1.0 grams of yam? Please, kindly solve this and tell us the answer. And if you have more questions, kindly bring in the questions. We'll take it up from there. Do not forget, kindly go to your Play Store, search for Proj Connect for you to get started to get more exciting and educative videos for undergraduate university students. This is specific heat capacity we have discussed today in chemistry, which is a 100 level topic, mostly in first or second semester, okay, depending on the university or the polytechnic or even the college of education involved. So viewers, I remain your pro guide Aisha Wendy. Thank you for watching. See you in my next class and bye for now.